Hey guys, welcome back. We're going to start our last chapter for this unit that we'll be doing before Christmas. There's only 4 parts to this to experiment, so really 3, and then the 4th one will be just a review assignment. So 4 more assignments to go, counting today's assignment. We've got, let's see, about 3 more weeks left of school. So if we are able to go back in person anytime really before Christmas break, we'll do a in-class experiment. I call it Gummy Bears in Space, where we'll build catapults and launch fruit snacks and see how far they go. It's a riot. It's a ton of fun. For about an hour and a half, we'll just do the entire lab activity, plot the points, re-express it. We'll have ourselves a lot of fun. Okay, but if we're not able to go back, then really we only have 4 assignments, a practice test, and the unit 3 gathering data test to take before Christmas break. So we should have time, hopefully, for you guys to get caught up on your assignments and stuff like that. So let me know as you guys need help as we keep going through here. I know distance learning is a challenge, and I really wish we could continue on in person, but I'm not too sure about that for the last 3 weeks. So hope you guys enjoy your Thanksgiving break, and let me know if you guys need any help. Okay. All right. So experiments and observational studies. So I teach honors math, whether it's honors geometry or stats, AP stats, and I notice I have a lot of students who play musical instruments, who are either in band or an orchestra, and whenever I go to concerts, I recognize probably about half of all the students that are in orchestra are one of my either former students or one of my current students, which is pretty stinking cool. So there's really there's an association, we would say, between students who are in honors math or between honors math and an orchestra. So our orchestra director and I, we know each other pretty well, and we have a lot of the same students. So it's pretty cool. Myself, I was in orchestra, play many stringed instruments as well. Of course, you guys have seen, but so it's kind of cool. So the question we have is, there is some association between playing an instrument and better GPA or academic performance, however you want to measure it, or honors math, as I would say. But is it instruments that are improving the GPA, or is it that students that have higher academic performance just tend to enjoy playing instruments? So that's the real question. And there's a lot of people who would think that forcing a student to play an instrument would improve their GPA or something like that. So we want to see, is there just a casual association between the two? Is it just that people who play instruments just tend to have better GPAs, or people who have higher GPAs tend to play instruments? Or is it a causal relationship? Is it that instruments are causing higher or improvements in GPA? Okay, so in order for us to be able to decide that, we have to design a carefully designed experiment, which is what we're going to get into right now. So what helps student performance? Is it sleep, like Sleeping Beauty over there? Is it athletics, like dodgeball? Does that improve student performance? Or instruments? Lots of parents, of course, want to know what can they do, or what activities can they be involved in with their child in order to improve their academic performance. So is there a link between music education and good grades, like, for instance, straight A's? So the average GPA of students they took in some high school, they took students that were involved in some sort of music, I guess, including choir as well. So choir, orchestra, band, so any sort of music. And they took non-musicians, and the GPAs of the musicians were average GPA of 3.59, and the non-musician GPA was 2.91. So could this also just be students that are like involved in anything at school, and the students that are not involved in anything at school? So could that be what's going on here? Also, could the GPA be skewed obviously towards the left for students that are failing? Right now, unfortunately, the Pirates, who don't do anything, our GPAs are probably not too hot right now, so we're working on that, right? You are, and I am, right? The other thing is musicians made, or 16% of musicians had straight A's, where only 5% of non-musicians had straight A's. So it does seem, between just looking at the data, there is some sort of association going on between the two. It does not appear to be the same group. There tends to be a difference between musicians and non-musicians and their GPA or straight A's. So the question is it a cause and effect relationship? So is GPA, so students with higher GPAs, do they tend to enjoy music, or is it that just people that that enjoy music actually improves the GPA? So is GPA causing people to be musical, or is it that people who are musical tend to have higher GPAs, or neither? Or is there some sort of lurking variable at play here or confounding that's causing us to see increases in both of them at the same time? So good questions. So the difference we have between an observational study and an experiment. So far what we've done is just an observational study. I've looked at trends that I saw in nature. For instance, I tend to see that a lot of my students in honors math also tend to also be in orchestra. That is just an observation that I've made. There's no manipulation going on. I'm not forcing kids to do orchestra or not to do orchestra. I'm just noticing a trend in nature. That's what we would call an observational study. There are two different types of observational studies. We have prospective and retrospective. So prospective, well, retro, you can probably guess, like retro is in the past. So a retrospective study is whenever we have our observations. And so, for instance, people that contracted a rare disease or cancer in a certain town, like Flint, Michigan. And then we look at these people that contract this issue or whatever, this rare disease, and then we look back into their food logs. We look at their exercise, the environment where they're around, and we try to figure out, is there some trends that we're noticing between these people that developed this disease? Did they all have similar genetics? Did they come from the same family, et cetera, et cetera? What can we try to find and try to see? There's actually things with COVID where they're talking about like type O blood or something like that. So those were observational studies, right? They were noticing trends where people with certain blood type tend to have fewer positive tests for COVID and stuff. So anyway, an example of an observational study. Then we have prospective observational studies, which is when we select people. This is usually when we're not dealing with rare diseases, right? We select people in advance, and then we have them do a food log, or we don't force them to like diet or anything like that, but we just have them keep track of all the things that they're eating and their diet, their exercise, their sleep, and everything. And then we see what happens with those people and see if anyone develops any issues or something like that. Okay, so the advantage of a prospective observational study, even though we're not doing any active manipulation, is that we can keep good records of what's going on. If we look at retrospective, we usually do this for rare diseases when we can't just expect somebody to get cancer out of a treatment, out of an observational study of like 200 people or something like that. We use retrospective. It's the best that we've got if it's a rare disease that we're studying. Prospective has the advantage of we know exactly what we're looking for. We can make sure we're measuring the data consistently instead of having to look back at medical records and stuff like that. Now, the other type that we have are experiments. So the key to an experiment is random assignment of treatment groups. Okay, so if you get nothing else, experiments, the main thing you need to know is there's an element of random assignment of treatment groups, meaning you don't get to pick whether or not you play an instrument or not. I'm going to assign you to the groups of people who get to play an instrument and people who don't get to play an instrument. So there might be a little bit of discomfort here because some people would be forced to do something they were uncomfortable with. Other people would be rejected the ability to do something that they wanted, like play an instrument. So there is this ethics part of experiments that always comes into play. Playing an instrument or not, that's not as big of a deal, but if you suspected whether or not a vaccine or a drug or something like that was safe, you actually have to like experiment with people, and some people have to be given it, whether or not. So if you think something might cause cancer and you want to prove that it causes cancer, you have to be willing to let some people like be exposed to that. Yeah, ethics comes into play. All right, moving on. So are the two groups random is the question we have. So are musicians just a subset of smart people? By smart, I'm just saying high academic performance or GPA, however you want to measure it, or honors math, whatever. Or are we assigning the music? So we randomly assign music and no music. And when we randomly assign those groups, the people who we made do music had higher GPAs than the people we did not. So if this was the case, that we randomly assigned the groups, then there wouldn't be any choice involved in it. We would be able to correct for any lurking variables, and we'd be able to say that it was the music itself that actually caused a statistically significant increase in the GPA for us to state that music itself is actually increasing academic performance measured by GPA. Okay, so if it's not randomized, we can't say that it's the music doing it. There might be other lurking variables at play. So examples of lurking variables will clearly supported parents. So someone's paying for those lessons, whether you take lessons or not. I never practiced and I never took lessons. I just did the free public education stuff, viola, for 9 years. But anyway, still, supported parents, instruments are expensive, right? Or paying for lessons. Also, could we simply be measuring wealth? Like, remember when we talked about the life expectancy and the number of televisions or something like that? So countries that had more television sets also had longer life expectancies, but what we were actually measuring was a lurking variable of wealth. So wealthier nations or whatever that had more access to televisions or whatever, luxury items like that, also tend to have better healthcare and longer life expectancies. So could it be just a lurking variable of wealth? So it's socioeconomic status and academic performance. Of course, those two are tied together. And so if you have more supportive parents and more wealth, then perhaps that's what's showing up, and not actually the fact that you play an instrument, but rather that you can afford to play an instrument, or that you have the time and the leisure to be able to do that. Perhaps, I'm not sure. So other questions that we might want to answer that we might be able to design an experiment is, does vitamin C reduce cold? So we have two treatment groups. You have some people who are given vitamin C, some people are not given vitamin C, and we see if a statistically significant difference between the amount of people that develop a cold throughout a cold season over a few months or something like that. All right, so is a medication effective and safe? So the two questions the FDA asks. So is the treatment, is it effective? Does it show a statistically significant difference between that? So the latest Pfizer COVID trials for their vaccine was 95% effective, so at reducing the spread or preventing the spread of disease, which 95% over whatever the value was before would clearly be statistically significant. So yes, it is effective. Then the only other question we have is it safe? A lot of times that takes a long-term thing, but I think they believe that it was safe, but I don't know. I don't actually do this stuff. I just teach stats. So elements of experiments. So here's kind of a diagram of the experiment going on. So we take all of our students, let's say we take all the students in sixth grade. So we have two treatment groups. So we have 500 students, 250 of them we randomly assign to play an instrument. We'll let them pick the instrument, but they have to play an instrument. And the other 250, the other half, we randomly assign them to not be able to play an instrument. I mean, we're barring them from playing any sort of instrument or being involved in choir, band, or orchestra. Sounds kind of cruel, doesn't it? Again, ethics. And then after that, we're going to bring it back the groups together and measure their GPA. So what was the average GPA or percent of A's, straight A's, or however we want to measure the academic performance, okay? GPA is probably the easiest way to do it, right? And then if there's a statistically significant difference between those two, because they were randomly assigned, we can say that it's kind of controlling for outside factors and stuff like that. We would be able to say that it was music itself that caused the increase in the GPA instead of other lurking variables. So this random assignment is how we actually control for the outside lurking variables, which is wonderful and very, very important. Otherwise, we can't prove a causal relationship. We could still observe a trend in nature with an observational study, but we can't prove that there's a causal relationship between those two, which is something we've been wanting to do this whole time, right? So our subjects are going to be our students. We also call them participants if they're humans. The factors are going to be whether or not you play an instrument. Okay, the levels of the factors are going to be two levels. So the factor that we're trying to see whether or not fear is a factor for you, right? So we're trying to see if music is a factor of GPA, right? And so there's going to be two levels of that, whether you have music or no music. Okay, so that's factor levels. Then the response variable is going to be what we measure at the end. So here we have our subjects or participants in this case because they're humans, not like lab rats or something like that. You know, we give nice names to them when they're people. The factors are at two levels, music or no music, and then the response variable, which is what we're measuring. Remember, like the explanatory variable, which is the x-axis, and the response variable is one that we're interested in, is the y-axis. Our response variable in this case would be the GPA. All right, so other questions we might have about sleep and exercise. How does sleep and exercise impact performance? So it's pretty well known, or at least we observe trends, right? People who tend to work out and get a lot of sleep, that would actually impact academic performance as well. So if we wanted to design an experiment to see how much sleep is a factor, or exercise, or the combination of both of them, or whatever, to see which treatment group is the most effective, we might make an experiment that looks like this. So we're going to have two factors. In this case, we're going to take all of our students. We're going to have two factors, which are sleep and exercise. So I color code them for you here. We're going to do 3 different levels for sleep. We're going to have them sleep for 4 hours, 6 hours, or 8 hours. Clearly, the 8 hours is going to be the best. 4 hours of sleep is no bueno. Then on the exercise part, we're going to have them either do 0 minutes of exercise. We're going to force people to have sedentary lifestyles. Now, as Americans, it comes naturally to me, right? And then stereotypes. All right. Then 30 minutes of exercise. So we're going to force them to do 30 minutes of exercise, whatever that might be. So our different combinations of those two factors, which will give us all of our, and their levels, will give us all of our treatment groups. So this group here is only allowed 4 hours of sleep and is not allowed to exercise. I mean, some of you guys are like, yes, that's what I do every day. And then all the different combinations until we get to the very end, which is probably the healthiest, we would assume, right? Which would be 8 hours of sleep and 30 minutes of exercise. Probably a good idea, by the way, right? So we're going to randomly assign the students into these treatment groups, and then our response variable for academic performance, we look at grades, GPA, whatever you decide that you want to use, that's fine. So we're going to compare them between here. Now, the important part, again, is that we're randomly assigning these treatment groups. We don't let people pick. So perhaps students that are doing better academically, are more motivated, have better schedules and time management, and they enjoy being involved in lots of activities like you guys are in AP stats, definitely. And so you guys clearly get 8 hours of sleep and clearly are exercising and walking and getting your steps in on your Fitbit and your Apple Watch and all that cool stuff, right? I don't know, right? So the problem is that we don't want to let people choose what treatment they naturally fall into. We want to randomly assign them in those treatment groups, meaning the AP students are just as likely to get this treatment group as they are in this treatment group. And the students who are less motivated are just as likely to get in this treatment group as they are in this treatment group as well. And so that mixture would allow us to see whether or not it's the treatments themselves instead of the people's natural tendencies to have healthier or less healthy decisions, which would result in their grades and their study habits and their performance. Okay, wonderful stuff. All right, so an observational study is a study based on data which no manipulation of factors has been employed. So again, you're just observing natural trends. So if you look at the picture here, this guy in the camo hat is just observing the rhinoceros. I have no idea what he's observing, but he's hands off, right? He's just sitting back there and just observing what's going on, okay? We're not actively manipulating anything. We're just observing trends in nature. So for my example, I observe that I have a large amount of students that are in orchestra that are also in honors math. That would be my observation. Retrospective study is an observational study where subjects are selected, then their previous conditions or behaviors are determined. So we look at the past. We select them probably because they had some rare disease or cancer or something like that. And then we look in the past, their past behavior, diet, nutrition, whatever we might find. Environmental conditions, like if they work in coal mines or something like that, or they drink the water in Flint, Michigan. Oh, so much fun. Anyway, that is going to be the previous condition. That's a retrospective study. Okay, we look at the past and try to draw some, see if there's some natural trends that we can notice. Anyway, prospective study is an observational study where subjects are chosen and then followed to observe their future outcomes. So this is where we're able to keep a accurate daily log for their exercise, for their nutrition, for their sleep records, all that stuff we're interested in. We're not going to tell them how much exercise to do. We're not going to tell them how much sleep to get or what to eat or what not to eat. We're just simply going to make sure that they're keeping an accurate log of that information. So prospective studies are beneficial in that sense that we can keep accurate records. We're retrospective. We've got to remember what happened in the past, and it might be a little bit iffy. Okay. Well, a lot of times we look at like health records and stuff like that, and for retrospective. All right, in experiment, we randomly assign or manipulate factor levels to create treatment. So basically combinations of different factors and their levels give us all the treatments. And then we randomly assign the subjects to these treatment levels, then compares the response variable, whatever we were interested in, of the subject groups across the treatment levels. So in this case, correlation is can be equal to causation if it's a carefully controlled experiment that can prove a causal relationship between cause and effect between two things. So not just is there a positive linear association between the two, but is it a causal relationship? Is our explanatory variable causing our response variable to increase as well? All right, let's go ahead and get into the assignments, right around 20 minutes. 2. Researchers who examined health records for thousands of males found that men who died of myocardial infarction, I have no idea, aka a heart attack, I know what those are, tended to be shorter than men who did not. That's funny. Okay, so a researcher who examined health records in thousands of males found that men who died of a heart attack tend to be shorter than men who died. Okay, that was interesting. Is this an experiment or is it a observational study? So the key thing you need to look for in an experiment is the random assignment of treatment groups. So we are randomly assigning people to be short or to be tall, and then if they were randomly assigned to be short, then they tended to have more heart attacks. That's asinine. That's not how that works, right? So this is clearly an observational study. So researchers noticed, looking at a retrospective study, because they looked at their health records, right? So they found the men who died of heart attacks, and they looked at their health records, and they found that they tended to be shorter than men who did not. So anyway, this would be a retrospective observational study. Is it correct to conclude that shorter men are at a higher risk for heart attack? Again, the only way that we prove a causal relationship is not observing natural trends in nature, but by randomly assigning treatment groups in an experiment. And since it was an observational study, it was just some trend that we noticed. We can't prove a causal relationship. We don't know which direction it goes or if there's a lurking variable at play here. Components of an experiment. All right, random assignment. So to be valid, an experiment must assign experimental units to treatment groups at random. So this is called random assignment. That's the whole point. All right, factors. A variable being manipulated by the experimenter. Experiments attempt to discover the effects that difference in factors levels have on the response of the experimental unit. The response is a response variable whose values are compared across different treatments. If in a randomized experiment, large response differences can be attributed to the effect of differences in the treatment level, right? So a large response differences we're going to call a statistically significant difference. Now, we'll learn how to measure whether we can quantify statistical significance with p-values whenever we come back from Christmas after we do probability as well, okay? But if it's, what we're going to say is if the difference was large enough that it would not naturally occur, then we would say that it would be statistically significant. So it's not likely to have occurred by chance is the kind of the key phrase that we're looking at there. All right, experimental units. Individuals on whom an experiment is performed, such as people, plants, animals, or objects. Usually they're called subjects. Human subjects are called participants because they're people and they have their own free will and volition. Alrighty, and moral agency. All right, philosophy. Level, the specific values of the experimenter chooses of a factor. So the factor levels, right? So like 30 minutes of exercise, an hour of exercise, 0. Those are 3 levels to 1 factor. Manipulated conditions are also called levels of the factor. No big deal. Treatment is the overall combination of factors and their levels is called a treatment or a treatment group. So the process, intervention, or otherwise controlled circumstances applied to randomly assigned experimental groups or participants. Treatments that are different levels of a single factor are made up of combinations of levels of 2 or more factors. So it can be multiple factors or just one factor with multiple levels. Anyway, as we kind of looked at anyway. All right, number 10. Is diet or exercise effective in combating insomnia, which is the inability to sleep? Some people believe that cutting out desserts can help alleviate the problem and help you sleep better, while others recommend exercise. 40 volunteers suffering from insomnia agreed to participate in a month-long test. Half were randomly assigned to a special no-dessert diet. The others continued to eat their desserts as usual. Half the people in each of these groups were randomly assigned to an exercise program, while the others did not exercise. Those who ate no desserts and engaged in exercise showed the most improvement. Okay, kind of cool. So we have 2 factors here and at 2 different levels. So our factors are exercise, our factors are exercise and dessert. Okay, the levels for each is 2, right? So you either exercise or no exercise, and then you have dessert or no dessert. Is this an observational study, retrospective or prospective, or an experiment? So are we randomly assigning treatment groups? Well, keyword here, randomly assigned. So yes, definitely randomly assigned to the treatment group. So this is an experiment. Who are the subjects that we studied? 40 volunteers that had insomnia. What are the factors in the experiment and the levels of each? So the two factors, again, like we said, are desserts and exercise at 2 levels each. Yes and no, right? So either they had an exercise program or did not, and whether or not they had, they were allowed to eat dessert. Is diet or exercise effective in combating? Okay, same thing. D. What are the total number of treatments? So we had 2 levels of two factors at 2 levels each. So altogether we'd have 4 treatment groups, the combinations of those. Okay, so 2 times 2 would be 4. In other words, what are the response variables measured? So their sleep levels. So how many hours of sleep they got, whether or not they rated from 1 to 10, how well they slept. I don't know. But sleep quality in general would be the response variable. What is the nature and the scope of the conclusion? So the nature and the scope of the conclusion is basically another way of asking, can we prove a causal relationship? Well, if this was a carefully designed experiment with randomly assigning treatment groups, then we would be able to say that there is a causal relationship, and there was. So because it is a randomly assigned and carefully designed experiment. So we would be able to say that not eating desserts and having exercise showed the most improvement, meaning that caused you to sleep better, which is nice. Good to know. All right, is this an observational study? Or among a group of disabled women aged 65 and older who were tracked for several years, those who had a vitamin B12 deficiency were twice as likely to suffer severe depression as those who did not. So they're trying to see if there's a link between vitamin B12 deficiencies and depression between older women, 65 and older. Is this an observational study, retrospective or prospective, or an experiment? Are we randomly assigning B12 deficiencies to 65-year-old and older women? No, we're not. So this is not an experiment. So it is a study. Is it an retrospective or prospective? Did we select the people first and then look at their past? Or did we select people and then we measured things as we went further? So among a group of disabled women here, they were tracked for several years. So the fact that they were tracked for several years tells us they were selected first and then tracked, not selected and they looked at their past. Okay, so this would be a prospective observational study, or just a prospective study. Who were the subjects studied? That would be a group of disabled women 65 and older. What's the parameter of interest? So this is the population parameter. Yeah, so the population parameter of interest. We were interested in seeing whether or not they had depression issues, or suffered from severe depression. Can we prove a cause and effect? This is a trend that we noticed. This was not a randomly assigned treatment, and so we cannot prove cause and effect. We can just say that there was an association between the two, not that B12 deficiencies caused the rates of suffering from severe depression to increase. Wow, so depressing. Just saying the word depression is depressing. It's okay. We're going to get through this together. What is the nature and the scope of the conclusion the experiments can reach? So again, we can only show there's an association, not a causal relationship, because it's not an experiment. Is that it? Am I done? 20 minutes. Okay. That's it. So I hope you guys enjoy your Thanksgiving break. We only have 3 more assignments after this one today, and we'll do a practice test and the test. Hopefully we're able to go back in person and do that really fun catapult activity. If not, we'll just do it when we go back, whenever we go back. I don't know. We'll make time to have fun. That'll be really important because I have to, otherwise it's not worth it to me. But anyway, I will see you guys later. Let me know if you need anything, please.